All right. I'm thrilled to be back. I live quite close to campus, but I'm rarely back here. I live right over in Arlington. And I have to say, just now, this lecture series got started the year after I graduated. I'm feeling very envious because it seems like a great kind of connecting force. Uh, but anyway, uh, my title, Tackling Carbon Resilience and Ambivalence, Lessons Learned from One Decade in Sustainable Architecture. I think we're partway there. We still have a lot of work to do. And if anyone here is very interested in joining us, that's a wonderful thing. So when I remember the day that I decided that I wanted to go into architecture. And I was sitting, it was the spring semester of my freshman year. I was taking this large survey art history course that started with ancient and went through to present day. And one of the last lectures of the class focused on contemporary green architecture. And I just felt that I knew immediately that that's what I wanted to focus on. And from there, I decided that I should become a double major in architectural studies and environmental studies. And for context, at the time, the campus looked quite different. So this was back in 2007, and the only LEED certified building on campus was Sophia Gordon. And I remember it had this kind of mystique, both for me and for much of the student body because of that certification. And I just wanted to recognize a few faculty members who were kind of particularly helpful and or inspiring to me at the time. First and foremost, my thesis advisor, Daniel Abramson in architectural studies, as well as these three folks from environmental studies with environmental toxicology, hydrology, and water resources engineering, and politics of political cities. So each of these courses, they were, it's seemingly unconnected, very different disciplines, in some cases very challenging. The hydrology and water resources engineering course was really predominantly graduate students who had done quite a lot of modeling. So I was a little bit in over my head, but I learned so much. And all of these topics are still relevant to my work today. And I think that's part of the power of the major, that it can tie together all of these different disciplines and allows students sort of the flexibility to explore topics that they previously had no exposure to. So I encourage you to push yourself into new areas, even if they seem challenging. So why buildings? I think, so for the rest of this talk, I'm going to be talking a little bit about the role that I have now, my perspective specifically on campus decarbonization, because my work does, or my firm does almost entirely higher ed. So I can kind of compare what's happening on a lot of different campuses simultaneously. And I'm also going to focus on a project case study. And through all of that, I'm going to sort of continually be referencing back to what has changed in the field over the last decade and what I hope will change in the decade to come. So the building sector is a huge polluter. It represents about 40% of global emissions, both through operational carbon and embodied carbon, and which means the carbon impacts produced through the manufacturing of materials over the course of their life cycle. And if you're wanting to keep us on one of the lower trajectories in terms of increases in global temperatures, the time value of carbon is very critical, right? So we want to be making more significant carbon reductions earlier, which means that it's critical to be focusing on upfront emissions rather than just operational emissions, which will kind of are more gradual over time. And what this means for me and my practice is that really the best projects in terms of carbon impact are existing buildings, and figuring out how to save as many existing buildings as possible and kind of minimize the need for new construction is very important to this picture. And it's just another chart indicating the, real significance of this sector. Construction materials is in gray. You can see it dwarfs all other material impacts. And of course, buildings are so large that they sort of equate to, millions or hundreds of millions of these everyday products that we all consume. And in some cases, spend a lot of time worrying about, but they pale in comparison to the scale of building impacts. And we know that this trend is going to continue. Projections are that we will be doubling the current building stock between 2017 and 2060. So a lot of work for everyone in the building sector to try and minimize impacts over that period. So what does my job look like now? So I am Director of Sustainability at Goody Clancy, which is an education-based firm in Boston. We're about 75 people, and we've been around for about 75 years. There has always been a commitment to sustainability and existing buildings at the firm, but the structure of what sustainability leadership looked like has changed a lot over the last decade. And that's something that you can kind of see across the industry. So we use a sort of hybrid distributed model where we have 2 FTEs, myself and a building science specialist, who are fully dedicated to sustainability. And we oversee team-based sustainability champions who are embedded in all of the individual project teams focusing on individual buildings. And the internal team is really just a subset of the overall project team. So because we work on large, complex projects, we also have large, complex teams. So we don't always have all of these consultants on all projects, but we often have this many consultants, and there are additional specialty consultants that may show up on certain projects beyond this list. And I'm not going to read all of them, but a lot of them have direct and really significant connections to sustainability. So this whole effort is really a lot about coordination, and it's as much I would say more a communication challenge than a technical challenge. And if I'm tying back to the environmental studies major, I really feel that the interdisciplinary nature of it set me up very well to work in this environment. So, and I'm going to skip to the next one. One of the most important things that I do to support project teams is help them develop co-created goals with their clients at the beginning of projects. So that's really critical to actually driving sustainability outcomes, because if you just try and develop goals like within the design team and not with your client, they'll never be nearly as powerful. So co-created goals are very important. Especially in the space that we work in, because as I'm going to talk about, and I assume many of you here are familiar with this, just because of the great work that Tufts is doing. But there was an old kind of mindset within the industry that architects needed to sort of advocate to clients. But I would say that's something that's really been dramatically changed in the last 10 to 15 years, where many campuses have very ambitious climate action goals themselves. And so rather than advocating for clients or to clients, what we're trying to do is just help implement climate action plans that they already have in place. And so another part of my work that I really enjoy after the project goals have been set is helping with in-house analytics. So this is another thing that has changed in the industry. It used to be that more building performance analytics were conducted by our consultants, and I'd say we're kind of gradually bringing more and more of them in-house, and that makes us better and smarter designers. So this is just an example of wind analysis and sunlight hour analysis to help kind of optimize and expand the season of outdoor comfort in an outdoor amphitheater in a very hot climate. And this is sort of a lot of the analysis that we do is whole building based. And we also zoom in on specific building envelope details to understand like the heat transmission. So this analysis happens at all different scales and is really critical to our work throughout the design process. And then another aspect of our work that's changed a lot over the last decade is just improved operational energy and tracking. So we are signatories of the AIA 2030 Challenge, and we have been since before I joined the firm. And what that means is we're committed to tracking all of our projects and reporting them annually and making incremental reductions over time to try and drive ourselves down all the way to net zero by the year 2030. And we won't quite get there. No one is quite on track for it, but the whole process of tracking and learning from that tracking has been very effective. And I'll talk a little bit at the end about what that looks like across the whole industry. Okay, so campus decarb. I talk about this a lot. I've actually never talked about it on a campus before. So I'm sure that there are people in this room who know a lot more about this from the implementation perspective, but I will speak about it from the perspective of a practitioner. So there are so many schools across campus, across the country that have made climate commitments of different sorts. So many have signed the President's Climate Commitment and the 2017 We Are Still in Pledge. Some, and I believe Tufts is signatories on both of those. Some schools haven't even signed those commitments, and yet they've still published climate action plans, established carbon neutrality dates, and established fossil fuel free dates. So there's just a huge amount of momentum behind this in the campus space, and there's a lot of knowledge sharing happening across schools that I know Tufts participates in. So it's definitely a marathon and not a sprint. This is a very long and expensive process. I would say it's so expensive that it will, on many campuses, not all, shape capital project priorities in many ways over the next 2 decades. And as those projects move forward, the decisions made on those capital projects will conversely, make or break the school's ability to hit those targets on time. So the work that architects are doing is very important to actually meet these broader goals. So how do campuses talk about different emission types? We have scope 1, which are direct emissions from operations that are owned or controlled by an organization. Scope 2, indirect emissions from the generation of purchased energy consumed by an organization. This is electricity you're getting from the grid mostly. Scope 3, indirect value chain emissions. And this includes many different things, including embodied impact of construction materials, which is a subcategory of what you can see under there, capital goods. So what do I want to say about this? You can see the scope 3 emissions really dwarf scope 1 and 2, and yet scope 1 and 2 is where everyone has to start when they're talking about decarbonization. And so there are different ways to frame this, but one way is that embracing sufficiency and right sizing is a critical place to start, then reducing energy demands, electrifying building systems, generating electricity on site, buying renewable energy off-site, and buying carbon offsets. And I believe there was a lecture in February, perhaps, as part of this lecture series about specifically Tufts campus decarb. Show of hands, how many people were here for that? Okay, all right. So I assume everyone here who participated in that, a little bit of this will be review, but since many of you weren't, many campuses operate off of district energy systems. And so there'll be either a central or sometimes semi-distributed energy plant, and that distributes steam or hot water to all the buildings across campus. And so, you know, campuses have very different scales. Some are relatively small. We work on some campuses that have fewer than 10 buildings. Others are enormous. And the scale of the campus really dictates kind of like the timeline needed to make these conversions. And another really critical factor is what the state is of the existing building stock and what the state is in terms of the deferred maintenance challenges. And so when campuses are trying to convert from steam or hot water into lower temperature hot water, which can be fully electrified instead of relying on combustion, all of the buildings that are going to be connected to that system need to have better performing envelopes than what the original historic buildings would certainly have had. So it kind of creates this domino effect in terms of all of the projects that need to be part of this effort. So it's a huge effort, but that's still, like I said, the starting point. So almost all campuses that are grappling with decarbonization are starting by focusing on these, scope 1 and 2 factors. And then over time, they'll gradually often incorporate in a more meaningful way some of these other pieces. And this is a diagram that I created that maps out what campus decarb looks like across a number of different schools. I would say no single campus follows exactly this path. It's sort of an amalgamation, but and there are different types of commitments that campuses can make up front. So they might establish a commitment by signing one of those commitments previously mentioned. They might just share an initial sustainability vision or create kind of a more concrete climate action plan, or what many schools call a decarbonization roadmap. And somewhere in those early stages, they'll often do what I call a design model capital project. So some building on campus that is going up, they will specifically, they will have particularly ambitious energy targets for, and this could be new construction, it could be renovation, and it's an opportunity for the school to kind of test unfamiliar technology and also inspire people about the sort of power of these buildings. So, and then once they get through those sort of early stages, then they'll move into implementation, which on most of the campuses that we work on, because they're heating dominated, the technology that they're using is ground source heat pumps. So they'll be constructing the geo-exchange bore fields, they'll be upgrading buildings and zone level equipment, and constructing or upgrading the campus plants. And then sometimes that process has to be repeated multiple times depending on the scale of the campus. And it's only through completing all of those steps that they can actually eliminate on-campus combustion. So this is how that plays out on a number of campuses that we work on. And of course, Tufts could be up here as well with a sort of similar decarbonization date in 2050. But what I want to say about this is that even though schools are sort of trying to move in a similar direction, the way that it plays out timing-wise is really highly variable. And the way that architects plug into this can kind of be at any point in the process. So sometimes it's through assisting with early decarbonization planning work, or plugging into master planning work, which can also inform decarbonization. Sometimes it's through participating in those early capital project work. And other times it may be getting to design a project after a campus has maybe gone through the cycle 2 or 3 times, and they've learned a lot about what it looks like. So campuses are learning from each other as they go through this process, and we are learning from our work across the campuses as well. So for some of the remaining time, I'm just going to walk through a case study of a project that we were working on at Dartmouth that I would say qualifies more as that sort of early model project for the campus. So this is the Irving Institute of Energy and Society. It opened in 2022. It just recently achieved its LEED Platinum certification, has very low energy consumption, especially because it has some lab spaces in it at 18.6 kBTU per square foot per year. It's actually an addition to a large sort of previously energy intensive building called Murdo. And so part of the project was also working on the systems upgrades to achieve very significant energy savings in the existing building. And I'll talk a little bit more about the significance of that. So then beyond the actual kind of concrete savings of the project itself, it also has this kind of mission alignment and student engagement piece that's very important to the campus's overall decarb goals. Going back to the idea of very complex project teams, this is just sort of a list of the number of project stakeholders, both the design team, the client team, and the construction team. Oh, that's sort of an abbreviated list. This is trajectory at the time of design of the campus's carbon emissions. It's evolved since then. We were very strategic in terms of the systems that we selected to integrate with the campus utility upgrades that were planned. And so what did this look like in terms of goal setting? We knew that the vision for the project was to create a global benchmark for high performance design that manifested through these 4 goals of optimizing EUI to below 20, optimizing occupant comfort, minimizing mechanical cooling needs, and expressing energy performance through design, which resulted in these priorities, which resulted in these strategies. And we used these building components to kind of make up those systems. So this always looks very linear. It's not at all linear. It's very complex and it's very interrelated. And this is just the pieces. The people are as complex, and there are so many individual design decisions that get made that have to involve so many different parties and so many different disciplines. So, and I would say, especially on this project where we were trying to use very sophisticated passive systems, and I'll talk a little bit about that. So this is just an output from the energy model showing the different measures that were leading to different levels of energy savings. So this is how we got down to 18. And I said at the beginning that the existing building was very critical in terms of energy savings. And there's a kind of comment here about generally in the industry, and I'm as guilty of it as anyone because I've been talking about the addition, which is very exciting. But making optimizations with new buildings, it is great. It is wonderful to save that 40 kBTU per year. It's dwarfed by the savings of the existing building. So it's maybe less exciting, but numerically, it's much more important to be tackling the existing structures. And it's especially powerful if you can use an addition, if you can kind of leverage an addition to enable those upgrades. So this is what the outside of the building looks like I'm gonna focus on the glass pavilion at the center, which is actually a really important part of the building's automated natural ventilation system. And this is just a shot from the interior of the main atrium. All right, so, and this is a section of a very similar view that you were just looking at from the photograph. And so what this is diagramming here in blue is the airflow of the natural ventilation system. And so you can see that glass facade at the front is actually, it's a double skin glass facade, and there's a 3.5-foot air cavity that we're using, taking advantage of stack effect out through the chimney at the top. So this cavity gets very hot. That helps induce airflow through it, which is helpful because it extends the season, it extends the time frame in which the building can operate under natural ventilation. And so I would say one of the things as an architect that was particularly exciting about this project was that the architectural features themselves were really performing important energy functions. And that's always, you know, a wonderful thing to get to design. And so this is just a closer look at some of those air pathways. So on the outside, you know, it's going through that cavity at the front of the building. And on the interior, what appear to be kind of like decorative wood grills on the atrium side are actually the air transfer points where the outside air flows from the floor plate into the atrium before it goes out through the top of the thermal vent. Okay, so just a few minutes left. I'm going to cycle us through a couple of things that have really improved over the last decade, and then a couple of things that I would like to see improved over the next decade. So expanded and effective goal setting. We are better at setting quantitative goals and following through on them. So this might be kind of hard to read, but the category, this is a response from a survey that we sent out to about 100 design professionals who are focused on sustainability. And we were just asking them about their goal setting practices. So the categories here are net energy consumption, operational carbon emissions, human health indicators, potable water consumption, and embodied carbon emissions. And the colors, the dark at the top is almost always, and then often, sometimes never. And so you can see that operational or net energy consumption and operational carbon emissions are really powerful drivers on projects a lot of the time. Potable water and embodied carbon, not as much. But I think I would say embodied carbon is changing rapidly. The integrated team mindset, I've been talking quite a lot about that, but that's another thing that I would say has really dramatically improved over the last year. And this is just another output from that survey. How effective are each of these strategies in helping teams achieve their goals? It tends to be engagement and communication focused rather than about technical leadership or green building certification. And although I think all of them are considered helpful. And then what was the driving force? Who was the driving force rallying teams to meet the desired outcome? Integrated team, most important, rather than any of the individual design team members. Obviously, owner, client, very important. Okay, so this is going back to the 2030 challenge data. At the beginning of the presentation, I showed you a bar chart that had the EUI of all of the projects from our portfolio. These are charts showing all of the reported projects across the US over the last, from the period of 2010 to 2022. So you can see that it increased dramatically to 3.8 billion square feet in 2022. And also the number of firms reporting significantly increased to the mid 400s. So these are both, you know, pretty exciting trends. Another thing is that because we're interested in getting better at analysis and making more informed individual decisions, a lot of firms have developed kind of pretty specific niche tools to answer specific design challenges. So these are a number of tools. Most of them are open source. Goody Clancy worked on the CARE tool. Some of these others were developed by local firms or firms on the West Coast. But I would say they're in no way redundant with each other. They're all kind of well designed to answer a different type of question. And none of these existed a decade ago. So I think that's a wonderful thing. Okay, what do we need to improve? I don't think I've mentioned water much at all today. I certainly agree with this quote from the UN Secretary General that water is the primary medium through which we will feel the effects of climate change. We know that the built environment dramatically impacts the water cycle. And I think it's pretty urgent that we get more serious about making this a more powerful project driver in all climates, whether or not they appear to be water stressed. So prioritizing sufficiency and being realistic about how much we need to build in order to meet our carbon goals. If we think about the projected square footages between now and 2060 that I talked about earlier, that it's somewhat frightening, right? It will be challenging to meet our carbon reduction goals. And standardizing the use of future weather data. So I think this is a really important aspect of resilience. So when we do all of our energy modeling, that's based on, we use weather files that are from quote unquote typical meteorological years, and those are just based on historical averages, and they update them periodically, but they're not effective, obviously, looking forward. And so while there has been interest in using future weather data for a while, it's not consistently implemented. And this is just an output from a research effort that we're doing in-house with a co-op from Northeastern. And I'll just say quickly, if anyone here is sort of interested in this type of research project, we should talk. Maybe there is an opportunity. But this is output from the Boston weather data. And what this is showing is based on 4 different climate scenarios. And I think most people think that we're likely to be in the worst ones. Maybe a lot of architects just default to using 8.7, but just for reference, I mapped out all of them here. And you know, Boston, so here's where we are now. So there's not much difference in the scenarios. So we'll see, this suggests that we'll see sort of minor reductions in heating needs, and we will see very dramatic increases in cooling needs. You know, not surprising to anyone, but it is interesting that the cooling needs appear that they will outstrip the heating needs. There's sort of a dramatic reversal. So there's a lot to be working on here from an architectural perspective, and I think I'm excited to see what will happen with it in the coming years. And just finally, there's so much data being generated. I think as an industry, we still need to get a lot better about data management and organization and analytics. And so if anyone here is interested in that, there is a large need for your skills in our industry. And that's it. So thank you.
Thank you so much for giving us a peek of what it is like behind the scenes of trying to decarbonize college campuses, and also the challenges and excitement avenues for your discipline. Before we open it for questions, I was wondering if you could, given that there are so many students in the audience, give us an overview of what it was like to navigate the transition from taps to your first job and the progression from there?
Yes, yes. So when I left Tufts, I went directly into, a professional degree program at Columbia. So that was a 3-year program to get my MArch, and then I went directly into practice at Clancy, where I've been ever since. And I meant to say that on an earlier slide, so thank you for prompting me. But I will, so if anyone here is interested in pursuing architecture professionally, I'd be happy to kind of talk about what that looks like in more detail. Because there wasn't a large studio component here at the time, in order to prepare for going into architecture school, I did the Shape of Two Cities program for my junior year, which was heavily architectural studio based. And that's part of what helped me kind of make that transition directly.
Any tips on how to find your first job?
How to find your first job. I think don't be shy about reaching out to your network. And especially in architecture, there are a lot of really active local groups. Built Environment Plus, that's hosting the Green Building Showcase, that was mentioned earlier, is one of these organizations, but the BSA is one of the most active AIA chapters in the country. So if you were interested in finding a first job specifically in architecture locally, I would say that it would be a great thing to try and start networking by participating in those groups.
Thank you very much. So I do have other questions while people gather their thoughts. I was wondering where in the decarbonization roadmap you come into play, and also do you also work with campus liaisons to develop educational components? Because I know our own Office of Sustainability does a lot of work with the students. Is that part of the conversations when you meet with campus representatives?
Yes, in different ways. Sorry, remind me of the first part of the question.
Where you show it as a map of the different
Oh,
steps.
yes, yes.
So where do you
Yes,
come into play?
Yeah.
Where do you?
In terms of decarbonization planning, when campuses are working on their roadmaps, we can provide very important guidance on the most efficient way for them to deal with their deferred maintenance challenges. So we'll evaluate the existing building stock and evaluate the building envelope and how it's performing and what replacements are needed and what its envelope upgrades might be needed. And we'll make recommendations of both what changes they should make and what sequence makes sense. And that is an exercise that we sometimes do as part of studies of individual projects, or as part of teams with MEP engineers developing like the holistic decarbonization roadmap. And so in terms of student engagement, I think a lot of times it's only done in project-specific ways. So there's always interest in incorporating, in interacting with students during the design process to get student feedback as stakeholders. And so that's often a sustainability discussion, but that's more about us learning from them than vice versa. When a building is completed, where we will often develop signage or some other form of green building kind of education to help illustrate for the community that will be using the building sort of what the best practices would be for users, as well as just sort of highlight for them what some of the most notable features are, so they can sort of appreciate the space that they're in. But it's mostly focused on those specific things rather than sort of broader education.
So you keep mentioning teams,
Yes.
And you showed a lot of slides with lots of people, and I can imagine it gets quite chaotic sometimes.
Mm.
You specifically had one slide where you showed, looks very linear, but then the next slide showed there's all these interacting loops
Oh,
and
yeah.
things. And I was thinking about how do you know when you're hiring someone who's going to be effective working in teams? Because you said the whole process is very iterative. Well, you didn't use that word exactly, but that's what my interpretation was. And so clearly you're looking for people who can be flexible, work with others. How do you know when you found someone like that?
Well, if we find someone who's like that at the beginning, then I think you're very lucky. And I think that perhaps coming out of an interdisciplinary program is the perfect place to find people like that. But I also think it's a learned skill. And it's something that it's not necessarily a trait that people come into the field with as much as one that they develop over time through all of their project work.
So as a teacher, would you recommend that I do certain things to facilitate teamwork, effective teamwork, so they're better prepared to go work?
Oh, absolutely.
What should I do?
Well, you could run kind of mock so like sustainability charrettes where people are looking at goal set. You could kind of like assign disciplines to people. It could either be an interdisciplinary exercise where students who are actually in different disciplines are together and they're trying to come up with a shared goal together, or it could just be sort of a role play exercise where people are pretending to be from different perspectives. That's also very effective. But that's a great question. I could probably design a whole curriculum around that specific question, so I can think more and follow up.
So I noticed that you had a couple points that were really interesting about like the different kinds of carbon impacts that go into the actual construction. And I was curious if you have any involvement or knowledge of like how kind of demolition and how like dismantling of buildings might play into it. Like, is there any kind of planning that you and your firm are doing when you're building a building on campus or when you're refurbishing something or something like that, like about the planned dismantling of that building or like what the long-term plan is if something has to change eventually?
Yes. So we used to do, this is a very interesting and evolving topic right now. When you're doing renovations, you always have a set of demolition drawings. And recently, those have been, there's a push to convert that from demolition to just deconstruction. And just the term change is important because the idea is that what we're putting into this building or what we're taking out of it is not something that we want to be cavalier about what it's happening with. We want to be very intentional and we want to have a plan for it. And this is something that there is action for us to take both when we're designing a building and when we're participating in either end of life or a renovation. So just changing the name of the drawings, having in our project specifications, we can be quite detailed about kind of salvage instructions. Yeah, and that's another piece of it. There's the aspect of how are we planning for the end of life for the pieces that are in our building. And then it's also when we are selecting materials, are we helping create demand for salvage materials? And are we incorporating that into either our new construction or our renovation projects? And we're doing, I would say, several projects now that are doing pretty interesting things with salvage, and it's very exciting. But there's in some cases it is cost prohibitive, and that's one of the major barriers.
Okay, I'm not sure how concise this question is, but I think the thing that struck me the most is when you were talking about how retrofitting is so much more sustainable than new construction.
Yes.
And I'm in a lot of urban planning classes, which deal with like the dramatic transformation of public space. And I'm wondering how that puts sustainable architecture either at odds or at play with that field, and how we approach new development from a retrofitting perspective and not like a dramatic reconstruction, I guess.
Yeah, that's a big hard question. And I would say, you can't, without talking about a specific context, you can't solve every problem with existing buildings. Sometimes you have to demolish, sometimes you have to build, significantly, enormous areas of new construction. But I think that's where the piece of sufficiency comes in. It is important, like we do tend to be in a growth mindset, and there is value in that. And yet we want to make sure that when we are doing new construction, we are never doing more than we need to.
Questions? The back. In the meantime, I saw that one of your team players is designated as sustainability consultant.
Oh, yes.
This is something that I think a lot of our students are interested in getting into. Can you tell us more about the skills that somebody wanting to be a sustainability consultant can
Yeah.
develop?
Yeah, there's a lot of overlap with architects. It's not that there's like a big revolving door between the two, but sometimes people switch between the two. And so they perform a lot of different services on our projects. So I'd say one of the most significant is performance modeling. So I think, like I said, that we used to not do any, and between the mechanical engineer and the sustainability consultant, they used to do all of it. So there's a lot of energy modeling that sustainability consultants do. There's a lot of green building certification. They also are doing a lot in the space that we work in on campuses. They're also doing a lot of kind of like visioning guidance with clients in different ways. So they might work on decarb plans. I think, I mean, I have at points in my life wondered if I would be happier on that side than on the architecture side. But I think one advantage of being, within a design firm is that you do have that tighter feedback loop for more iterations than when you're outside. But when you're working as a sustainability consultant, they tend to work on more projects than architects do. So the benefit of being on that side is that you would get more exposure to more projects, and you would probably be working more closely with people with a variety of subject matter expertise across sustainability, whether it's, they might have a building envelope team, as well as an energy group, as well as a well-being group, et cetera, et cetera. So there's a richness to being in that sphere.
I was also thinking about, I've been walking around campus and I'm seeing buildings like Eaton Hall, which are being renovated right now. And I'm looking at like 574, which like, if you go inside, I hadn't been inside in a long time. I noticed that a lot of the building is like the very old timbers that was like from a refurbished building. And so I'm interested, you mentioned something about like reclaiming materials and like how that's cost prohibitive. If you, in your experience of working with college campuses, do you feel like there has been kind of on college campuses a reuse of refurbished materials? Like, have they been able
Yes.
to like reclaim
Yeah,
stuff?
yeah, no, they are. And I mean, it varies by campus, but the easiest way to reuse them is on projects that are undergoing renovation. It's pretty common to identify components in the building that might be about to be removed and to find a new use for them as part of the renovation. That's sort of the easiest path to salvage when it's already on site. When it has to move, like come on from outside of campus into the building, that's when it becomes either equal or more expensive than virgin materials, and that's a harder sell.
I was just wondering, with the comparison between working on campuses versus working on maybe a city project or an industrial project in
Yeah.
the space of sustainable architecture, just what are the, I guess, differences as far as cost, maybe scope, ambition, timeline that you hear from your colleagues or just within that field in general?
Yeah. Yeah, I do kind of have kind of like a singular focus on higher ed. I think there are in other sectors, I would say it's not that there aren't very ambitious clients, there absolutely are, but there's probably more variability. And it also depends on what region you're in. But I would say each sector has its own things that they tend to focus on. So I'll give an example, which is, many passive house projects that exist are residential. Even though it's called passive house, it in no way needs to be constricted to residential. So that's the residential sector, I would say, has been leaders in envelope performance and energy efficiency through that certification. And then in the commercial sector, the WELL standard, which is focused on human health, has been most widely adopted for the commercial sector because some of the benefits associated with it are related to productivity and efficiency and happiness. So it's sort of a good match in that way. So I would say it's hard to answer for every single distinct sector, but most sectors have their own opportunities to push really hard.
To what extent do federal, state, and also local policies play a role in your architectural design process?
A huge role, and I was going to talk about that, but I was going to take too much time. So is everyone here familiar with the Mass Energy Code? Then, okay, so Massachusetts is passed really much more stringent energy code that different communities can choose to opt into. It's called the Specialized Stretch Code or the Specialized Opt-in Code, and it just came into effect at the beginning of the year, and it's pretty exciting. It's certainly mandating that basically all new construction and many renovation projects are going to be ultra efficient, and the most effective drivers are really regulatory drivers, because until the point that you have a really stringent code like this that kind of necessitates that almost all construction going forward is really efficient, a large percentage of buildings that get built will only default to the code minimums. And we know this because we have all this 2030 data, and when you compare how average projects are performing against the local code regulations, there's not that big of a delta. So they're paramount. And architects, one of the most important things we can do is advocate for better regulations. And I would say the Massachusetts community has been very effective in that way, and that's an ongoing effort.